So solving quadratic equations. You all know the basic general form of a quadratic equation, and technically any point on this parabola is a solution. But when they say solving, they're implying that we should find the x-intercepts, the roots, the zeros, and that happens when y is 0. So we stick a 0 in for y, and that's why they drum into our heads that you always set the equation equal to 0. We've been trying a bunch of techniques. One of them was factoring. Wasn't too hard. You set each factor equal to 0 and solve it. Unfortunately, it doesn't always work. We also did taking the square root of both sides. And that was pretty simple, but it doesn't work if there's a middle term. Completing the square was not so simple, but it does have the advantage that it always works. And they took completing the square, applied it to the quadratic equation, and came up with this beautiful quadratic formula, which is pretty impressive, and it always works. So before we get into the actual work, I'd like us to please notice that built into this quadratic formula, we have the equation for the axis of symmetry. X equals negative b over 2a. Right there, equation for the axis of symmetry. We also have what they call the discriminant. And that's the part under the radical, the b squared minus 4ac. And that's going to tell us how many roots there are and whether they're real or imaginary. So if the discriminant is negative, the b squared minus 4ac is negative. That means that we're taking the square root of a negative number. And you know that's not going to do well. We're going to come up with some kind of imaginary roots. And it turns out that the graph will not cross the x-axis. If the discriminant turns out to be 0, so that means we're taking the square root of 0. Well, if we're taking the square root of 0, this whole part disappears. We don't have plus or minus anything. So there's just going to be one real root. And the graph will cross the x-axis at just one point. It doesn't actually cross it, it just touches it. They sometimes call this a double root. Finally, if the discriminant comes out to be a positive number, then we're going to be taking the square root of, say, something like 6. And we are going to have 2 real roots. So the graph is going to cross the x-axis 2 different times. So enough background babble. It's time that we stopped and started some problems.